Okay, question 6 on that sample paper. The diagram below shows a quadrilateral WXYZ, so WXYZ, as well as its diagonals WY and XZ. Without measuring, perform constructions on the diagram below to show that the diagonals bisect each other. Show any necessary constructions line clearly. Okay, so the diagonals bisect each other, okay? So that means that the diagonals, which is these two lines here, cut each other in half, okay? Bisect. Bi is always two, but they bisect each other, they cut each other in half. Okay, so the diagonals. And we have to perform constructions. Okay, so how do you perform constructions? I'm going to do a separate video on this, but just to explain for anybody who has them done, okay, we'll first of all, we'll bisect this line. So you use your compass and you put your needle of your compass, we'll say into W first, okay? And you set your compass so that the width of it between the needle and the pencil is a little bit more than halfway of the line you're trying to bisect, okay? And what you draw then is, I'm going to draw it in red, well, I'll draw it in orange. You end up drawing a semicircle around like that, okay? So remember, my needle is in here and I draw my semicircle halfway like this, okay? And remember that distance has to be a little bit more than halfway. You then come down to Y and you stick your needle in Y. And again, you pick a distance that is a little bit more than halfway or halfway up the line you're trying to bisect, okay? And again, you would draw your semicircle as such, okay? And again, your needle would be here in Y, okay? You then get your ruler, and of course this isn't going to work for me, but anyway, you get your ruler and you draw a line between, let me just undo that. This here is called crosshairs. Do you see where the two lines cross? That's called the crosshairs. And you draw a line, a straight line between from this crosshair to this crosshair. Okay. I'm going to freehand draw this now. You know it's not going to go well, but anyway. Okay. And you draw a line between the two crosshairs, okay? And if I had drawn this properly instead of freehand, that point there would have actually been down here, okay? I would have been along this line here, okay? But of course I'm doing a freehand, so it's not going to work. So that's how you bisect a line. And to prove that you're right, you could measure that with the ruler and show that it's the same length as this one, okay? Now, won't be for my one, but that's the general principle behind it. Okay, so you can practice this, no problem at all. Just draw yourself a line, draw yourself a flat line on a piece of paper, call one side A, one side B, stick your needle in here, draw your semicircle, and draw the line then down the middle. Okay, so that's how you bisect a line. So that was for W and Y. You would then have to do the same thing for this line here. X and Z, okay? And again, put your needle in X and draw your semicircle. That wouldn't be far enough. Draw your semicircle and put your needle in Z and draw your other semicircle and then put your line in between. Okay, that one's much more accurate, okay? Well, in that I get the right point here, okay? So that's how you bisect lines, and that's what this question is done. The important part in any constructions is the construction lines. So these arcs, these semicircles that I have here, these are the important marks in a construction. And if they're not there, you will not get full marks for it, okay? Because if they're not there, there's nothing stopping you measuring this line and just literally drawing a line down the middle. Okay, so the construction marks are really important. Okay, now, why does the semicircle have to be more than halfway? Well, the reason for that is as follows. Let me just rub out this one and I'll show you. Okay, let me draw a line. Okay, so if I'm putting my needle in here now and I'm going to draw my semicircle, okay? And then in blue, I'm going to put my needle in here and I'm going to draw my semicircle. So you see, if it's not more than halfway across, these two semicircles will never intersect. And we need them to intersect so that we have these crosshair points, because it's from one crosshair to another that we draw that line to bisect the line. Okay, so that's why it has to be more than halfway. If you go too far, what ends up happening is that you get a big, huge semicircle around like this, and you have to kind of make a big, huge one so that they cross. Okay, so that's why you go a little bit more than halfway. Okay, like I said, we'll do videos on them on constructions later on this month. Okay, let's go to part B of that question. The diagram below shows the parallelogram ABCD. Its diagonals meet at the point O. In this parallelogram, the angle DAB, so this angle here, DAB, is equal to angle ABC. Okay, how do I know that? Just in case anybody hasn't had practice in reading this maths language. So it's the angle ABC. So start at A, B to C, and it's the angle enclosed by the two lines, okay? Or it's the letter in the middle. That's how you know it's that angle they're talking about. A is in the middle here. That's how I know it's that angle. And it's the full angle. It's not half of it. It's not just this part here. It's the full angle because the line started at D and ended at B, okay? So it's that full angle. So those two angles are equal, okay? And for anybody who knows their shapes, there are not too many shapes where these two corners, these interior corners, are equal, okay? In other words, a parallelogram, you can see that that's an acute angle. It's less than 90 degrees. This is an obtuse angle. It's greater than 90 degrees. So in a parallelogram, those two bottom angles are not equal. Okay, so I'm hazarding a guess that this is a rectangle, and we've all got 90 degrees in the four corners, and that the diagonals bisect each other. Okay, so it doesn't tell us that, so I can't assume it, unfortunately. So let's go on with the question. Prove that the triangle ABO is isosceles. So ABO. Okay. So I have to prove that's isosceles. Okay. So what does isosceles mean? Well, it means that the two base angles are equal and that the two sides are equal. Okay. So this side equals this side. That is maths language for equal sides. It'll also mean that the two angles, the two base angles are equal, okay? That's an isosceles triangle. Okay, so we have to prove that that is isosceles. Okay, so this is a proof, and it takes a little bit of practice of setting it up, because as you can see, you have no angles, no actual numbers for the angles. You've no lengths of sides, so you're working on all your what's called axioms and theorems and properties, all in that geometry chapters, to show that that's an isosceles triangle. Give a reason for your statement that you make in each proof. So that's really important, and you'll see me doing that now in a minute. Hint, it may help to show that the triangles DAB, okay, so I'm going to delete out this now, DAB is that triangle, and CBA are congruent. Okay, so that word congruent is the first thing. So this was a nice question. It told us how we go about the proof. So these are equal triangles. Okay, so equal triangles are all sides equal and all angles are equal. Okay, there's another type of triangles on your course, and they're called similar triangles. And it's quite easy to confuse the two. Similar triangles have all angles are equal, but their sides are different. Congruent, all the sides are equal, all the angles are equal. The two triangles are an exact copy of each other. Okay, so when you're proving congruent, there's a few ways of doing it. You can prove that all the sides are equal. So that's what we call SSS, so a side, a side, a side. We could prove that two sides are equal and an angle is equal. Side, angle, side is what SAS stands for. ASA stands for an angle, a side, and an angle. So we can prove that two angles are equal and a side, or RHS, right angle triangles are equal. Okay, so in all of these, we're showing that three pieces of information match in each triangle. So three pieces of information out of this triangle match three pieces of information out of this triangle. Okay, now how many pieces of information in a triangle? Well, there's three sides, three angles. Okay, so in total, there are 6 pieces of information in any triangle. But you can see for congruency, we need to only prove that 3 pieces of information are the same, and then by default, all other 3 will be the same. Does it matter which 3 you pick? Nope, not at all. Okay, so let's have a think about what is the same in this. So that triangle is equal, or that angle is equal to that one. Okay, so you're looking at the two triangles, the one I've drawn here in purple, and you are looking at this triangle and you're trying to see, okay, which, what could I say is equal? Okay, well, one very easy one to say is equal is this line BD. Okay, why can I say that's equal? Well, that line BD belongs to this triangle, and that line BD also belongs to this triangle. Okay, so I'm going to put triangle ABD here, and I'm going to put triangle, well, I'll write the letters in the order they have them there. So DAB and triangle CBA. Okay, so in DAB, I'm going to say that the side DB is equal to, and then in triangle CBA, I'm going to say that that side equals that side. So these two lines I'm drawing here, that's maths language for the length of. So that means the length of DB. So I'm saying DB, the length of DB in this triangle equals the length of DB in that triangle. And of course it does. Why? Because that's a common side. Okay, so now I've proven that a side is equal in each triangle. Okay, now let's see. Could I say CB is equal to AD? Okay, so that's a side out of each triangle. Well, I can't really, because they didn't tell me that the sides were equal, so I can't assume. And in the same way, I can't say, well, in theory, I can't say, in theory, okay? This is where your properties come in handy, okay? So if we think about the properties of a parallelogram, okay, parallelogram, okay, opposite sides are equal in length. Opposite angles are equal in length, and the opposite sides are parallel. Okay, I can't think off the top of my head any more properties, but there's some anyway, okay? So now there are the properties that I'm talking about that we have to pull out now to prove that these shapes are the same, okay? So because they've given us that an angle, this angle equals this angle, okay? Could I say that that angle equals this angle up here? Because opposite angles in a parallelogram are equal in length, okay? And again, if I draw a true parallelogram just to check that we're right, okay, you can see the obtuse angle there is opposite the obtuse angle here. The acute angle is opposite the acute angle, okay? So the 4 angles aren't equal, but opposite angles are equal. Okay, so could I say that the angle DAB is equal to the angle DCB. Why? Opposite angles in a parallelogram are equal. Okay, so that's an angle now that I have shown is equal. Okay. Now, I can't really use this angle because you see the way that angle crosses over the two triangles, this diagonal bisects it. So half the angle belongs to this triangle and half belongs to this triangle. Okay, so I can't really use the other angle. But let's go to opposite sides are equal in length. Will we do that one? So let's do the top. It doesn't really matter. So DC equals AB. Opposite sides in a parallelogram are equal. Okay, and that's another side. Okay, and see, so I'm not assuming, I haven't said anywhere this is a rectangle, even though my gut feel is it's a rectangle. I'm using the information I've given, and they told me it was a parallelogram, so I'm just using the properties of a parallelogram. Okay, so the last bit then you say is that the triangle DAB is congruent. See the three lines, that is maths language for congruent. The triangle CBA through side, angle, side. Okay, side, angle, side. Okay, so in other words, and you could put that down in English if you don't like maths language. Okay, that is perfectly fine to write that down in English. So they are congruent. Okay, so that's good. I'm going to say then, I'm just going to rub out the properties here because I don't actually have left myself enough space. So I'm going to end up working backwards. And I'm going to say also the angle ABC is equal to the angle ABD. Okay, and the reason I'm saying that is because if I draw my triangles the other way, okay, I am now saying that this angle here equals this angle here, okay, opposite angles in a parallelogram are equal. Okay, therefore, all angles are equal. Therefore, parallelogram is a rectangle. Another property of a rectangle is that the diagonals bisect each other. Okay, which means they cut each other in half, okay? Okay, which means that, I get the highlighter, that side is the same as that side, which is the same as that length, which is the same as that length, okay? They are all equal to each other. Okay, and you'd have proven that using this construction here, that the diagonals bisect each other. Therefore, triangle ABO is isosceles. Okay, so quite a lot in that question. Congruent triangles, very important that you can show the two triangles are congruent. It comes up a lot. So this is real paper 2 stuff. And then how to show something is true using theorems, using axioms, which are statements, and using just properties of shapes that you know that you've been doing at the end of national school, first year, second year, third year. You just never use them in this particular way. Okay, so it does take a bit of practice at these questions, and then we will do more of them.